I just want some sympathy. Can I get some sympathy?
You're the
Some
sympathy.
All right, stick with me, please. You'll need a calculator. Get out a calculator. It is conceptual, and some people just take to this right away. Some people it takes a little practice to make mistakes. I gotta say, that was me. When I learned this in college, my professor, I just couldn't. It was mostly me, but I didn't understand mostly what he said. Yeah, that's the other thing. You should not take for granted that I speak English in my first language. But this stuff, if you think this is hard stuff to learn, try learn it from somebody who's Polish. It's really, my Calc 1 professor was from Poland, my Calc 2 professor was from Japan. No, my Calc 3 professor was from Japan. My Calc 2 professor was from China. It's hard. It's hard. Okay, but anyway, here goes. The idea is like this. If you revolve a region around an axis, we've been doing that. But so consider, for example, if you revolve this region around the x-axis, then you'd get this kind of shape. Do you agree? Now imagine then, today's question is, what if instead of revolving it around the axis, you revolved it around something like a horizontal line that's way further? Well, in that case, then, the reflection of this would be substantially farther out, and you've got a much different revolution, probably greater volume because of that. And things have to change, obviously, to find that new volume. Now, depending on whether this line is above or below, things can start to get fairly complicated. If you just remember a few basic principles, you'll be very solid. First of all, volumes should be positive. If you don't get a volume that's positive, do something about it. And when I say do something about it, I don't just mean get out the eraser and erase the negative. I mean actually figure out what's going on. Why am I getting a negative? If negative, change the setup, not the answer. Because something is going wrong and you need to figure out what. If you will just use right minus left and upper minus lower, you will get positive components and all will be well. The first part I have here, this is a review of what we've done already. Now, do you feel like that would be a wordy 4 minutes? Okay, let's review that. I often have people say, well, how do you know if it's a shell or a washer and all that stuff? It's totally based on what you're revolving around and what variable you're trying to use, okay? It's not like you set out trying to use one or the other. It's kind of forced on you. So imagine if this region was revolved around the x-axis and you used x as the variable. First, tell me what is the slice going to look like. If I use x as the variable, is that a thin vertical slice or a thin horizontal slice? Vertical. Now, again, I understand that's fairly counterintuitive that an x slice would go vertically, but remember that's a reference to the thickness being very tiny in a horizontal fashion. That's why it's an x slice. With that revolve, then, the picture of that revolved around an x-axis tells you what you're going to be looking at. What are you going to be looking at? Shell, washer, or this? Washer. It is a washer, and we know that the big idea on washers is pi big R squared minus little r squared. Notice it's not r minus r squared. That's a very common error. The multiple choice gotcha. It's this, not this. Do you understand? Those are often thrown as a distractor, and you need to resist the temptation to fall into that trap. All right, so big R. Would that be, that's a vertical distance, I think you'll agree. And so upper minus lower, the upper being a varying point, but it's always on u, right? Are you with me?
Yes.
Okay, and the lower is always the x-axis, so it's just 0. So we would say that big R is u, and little r is the inside circle that's being removed. There's little r, the distance from the axis of revolution to the inner circle, and that is v. And because we're integrating an x slice, our differential is d x, and our limits, will they be 0 to a or 0 to b?
0 to A.
0 to a, because those are the x values of the region. Are we cool? It's important that you don't extend those. Remember, these limits of integration always refer to the original region, unrevolved. So don't think, oh, now it's b to negative b. It's just the original area, right? Before being revolved. What if that same revolution was done, so it's around the x-axis again, but this time I wanted to use a y approach. For whatever reason, maybe the equations are best done in y. Well, a y slice looks like that. What happens if you revolve a y slice around the x-axis? What kind of approach will be generated? A cylindrical shell. Do that. Okay. Now remember that the cylindrical shell amounts to the volume of a rectangular prism when it's unwrapped, but one of the dimensions is really going to correspond to the circumference of the shell. One of the dimensions is going to be a differential, so dy, dx or dy, and then the height will often be a little bit of work here. So it's 2 pi, it often amounts to the 2 pi rhd something, is the big idea of shells, right? For this problem, what's r? It's here. Yeah, upper minus lower. Do you agree it's a vertical distance? The upper, I'm not sure what to deal here because it's really dealing with both curves. Here, here, here. What's the upper? That's the kooky part. Well, imagine I had a number here at 2. What's the radius? 2. What about the slice here at 3? What's the radius? 3. So each time when I pull the radius, I'm really just looking at the y. Do you agree? Okay. So the radius is y minus 0, or just y. The height, that's this difference. That's a right minus left. And it's kind of varying on both sides. So what would you do for the height? What's the right? It's a point on v, right? Now, would I be looking at v in x terms or y terms? Y terms. So v in y terms minus u in y terms. dy is the slice. 0 to a or 0 to b? 0 to b. Okay. Now that's the region revolved around the x-axis using either variable. And it's nice to have 2 approaches because then you can check your work, right? All right. Imagine then if, I'm sorry I didn't do more pictures. I should have done more pictures so you can draw more. Imagine this time if you did the same region, but this time around the y-axis. I'm going to maybe draw this a little here so I have more room on this side. If it's around the y-axis, then I get that kind of shape. What if I used x? That would be a shell. Okay? So 2 pi RH, what's the radius? X, yeah, it's just wherever this point might be. That's what the radius would be, so the radius is just x. The height, that's the upper minus lower component. That's vertical, but it's varying on both cases, on both the upper and the lower. U minus v or v minus u? U minus v in x terms or y terms? X terms, dx from 0 to a, 0 to b. or negative A to positive A, or what do we got? 0 to A, the original region, not the reflected region. Don't worry about that, it's going to be, it's the original region, right? All right, and last but not least, y is the variable. If I use y, then the slices look like that. And I'm thinking about washers, okay? Now I prefer you to do basically just what we're doing, conceptually. I don't want you to memorize. A lot of teachers, I got to tell you, will have you memorize this kind of permutation chart of if you use a horizontal axis of revolution with x, then it's this, and it's just a memorized. I just don't. If that helps you, fine. That's definitely not how I teach it. I prefer you actually take each case conceptually. Okay. The washer is pi big R squared minus little r squared. What's big R? Yeah, it's the distance to V, because that's the outer, and the inner, U, and those would have to be in y terms because we're integrating with respect to y. 0 to A or 0 to B? 0 to B. Okay, now all that's review. It's all about the axis of revolution being at the x or y axis. Now let's stretch this out. Consider that same region, U and V. This time we revolved it around y equal negative 2. Now because we're using y equals negative 2 instead of the x-axis, the volume would be a little wider. It's got probably this hole in the middle that's substantially more, and so it'll look like that. 2 units to the point on either side of the axis of revolution. Now if I use an x approach, then my slices would be like that and revolve. I get a really big wide washer, which is really badly drawn, but you get the idea. Okay? Now let's get into the details here. We know washers are pi big R squared minus little r squared. What's big R? Okay. Here's the big radius. It's to this point now. So U is the upper minus the lower. Now what's U minus negative 2? U plus 2. Does that make sense that it would be 2 more units than if it was at the axis? Well, yeah, U is just the distance to the axis, so I'm going 2 more than that. So that makes more a longer radius, which is totally logical. What about the inner radius? V minus negative, so plus 2. With respect to x, and the limits are still 0 to A. Okay? Now then, that should be the same as if I used y as a variable, but the approach should be different. So if I did that same revolution around y equals negative 2, and this time I used y, and I would get what kind of approach? A shell, but the details are going to be different because we're not going around the axis anymore. Let's see which of the details, the radius or the height, will be different. What's the radius? Y plus 2, yeah. Everywhere these slices are is y, but I want to tack 2 more units onto that. Upper minus lower. The upper is a varying y. The lower is constantly negative 2. What's the height? Right minus left. So is that u minus v or v minus u? V minus u in x terms or what y terms if I had the equation? Y terms from 0 to b. All right, now that's the big idea. Let's get into some details where you actually have u and v. So here we go. Also, it gets different if this axis of revolution is below the line, the region versus above. Things start to get different. You'll see, it gets kind of crazy, but if you stay true to the core principles, you'll be good. So I'm going with the classic square root of x and x squared are the regions. But this time I'm going around y equals 3. So say you had y equals x squared, or f equals, or sorry, g equals x squared, and f equals square root of x. There's the region, basic enough. The axis of revolution, where do they meet, by the way? Just by guess and check. 1, 1. So they meet at 1, 1. That's cool. So we're going to revolve it around y equals 3. And when I revolve that around y equals 3, it's going to get popped up here. And I'll get this three-dimensional region, which I'm going to avoid drawing because my picture gets a little convoluted if I try the three-dimensional region. No, it looks pretty cool. It doesn't help me, which is the point of the picture. So if x is used, draw a slice of x. A slice of x looks like that, and its reflection. By drawing a slice and its reflection connected, it tells you what your approach is. Our approach is washer. Okay? Once I decide washer, I put the basic blueprint for a washer down. Big R squared minus little r. So, big R, is that a vertical distance or a horizontal distance? Here's big R. Is that vertical or horizontal? Vertical. How do I enforce a positive vertical value? Upper minus lower. What's up? 3. Yes. And the lower? They're kind of varying points on the lower curve. So they're 3 minus g. Okay. What about the points, the inner radius, which I'll do in green? Here's inner R. Upper minus lower? 3 minus 7. 5 squared. Now, these, in many cases I say you would be able to put this in your calculator, but these get kind of sloppy being put into your calculator. So I need you to practice this. Would you get out your calculator, please? And practice putting these in your calculator. If you're going to make your mistakes, let's make them now. But you need to be able to work out all the parentheses, and there can be sometimes quite a few of them. Don't forget the pi. Type in the pi right away so as not to be forgotten later. There's plenty of parentheses. In this case, it's not too hard to type in x squared and square root of x. And if it was an ugly function, I probably would store them in y1 and y2 and just call up y1 and y2 so as not have to type them on all the time. So the more complicated the functions are, the more likely you'll be to store them. Y1 and y2 or f1 and f2. G of x squared. Okay, answer? 5.341. Agree? Okay. All right. Let's say we found that same region, but this time we used y as the variable. So we have, just again, I'm just trying, I know we already have the volume, but I'm trying to get you practice on all the different approaches, x or y. It's good to have choices. So, same region, g equals x squared equals y. Same axis of revolution. 2, 3. But this time we're using y. So, graph a slice. If y is a slice, then it looks like that. Oops, that's really badly drawn. But okay, the y slice looks like that. So my approach is shells. 2 pi. From 0 to 1 still. Those are really y values now in my mind, not x. What's r? 3 minus y. 3 minus y. Good. Excellent. What about the height? It's more of a horizontal, right minus left. So it's the difference between the curves, but it has to be in y terms, right? So what is the difference between the curves in y terms? So here's the right side. It's on the square root function, but what's that in y terms? Square root y. Here's the left. It's the lesser. So I want to subtract it so I get positives. And it in y terms is y squared. It feels like that should be negative because square roots are less than, but remember for less numbers between 0 and 1, it's the opposite. Square roots are greater and y squareds are less. So throw that in your calculator. Because it's the same region, it should be the same answer. We just used a different approach. If it's not positive, you did something wrong, or we did something wrong. But I am getting the same answer. Are you with me? Okay. Let's try, now that one was around a horizontal line, y equals 3. Let's try one around a vertical line, x equals -2, and see how things change. Do you feel like you know enough to give this a go? Yes? No? Yeah? Okay. Give this a go, and we'll confirm and learn from the mistakes and make corrections as necessary. Same region. What's today? 6:13?
No, it's Friday.
Oh, 9. That's it. No, okay.
Is there a chance I can introduce this week?
Yeah, I can do it for you. You might be your own game.
Thank you.
Okay. Do calculate an answer, please, so you can verify numerically your responses come out the same. Although the integral setup should be different, the volume should be the same. What did you get for a volume? Did you get 5.131? Negative is bad. If you want to push me this much closer to a heart attack, go for it. If you care about me at all, please finish your mistake. What is the radius? Right minus left. The right is a varying horizontal position, so x minus negative 2 is plus 2. The upper minus lower for the height is the square root function minus the parabola from 0 to 1. That's how I got my answer. How did you do? If you did not get that, figure out what you did wrong, or ask why what you did wrong is not correct. Okay. How are we doing? Okay. I got the same for both. Did you get something like 5.131 for both? Yes? No?
Yes.
Okay. All right. As between these two types, this is the one that usually leads to more mistakes, especially negative. So consider one more example. Say you had that same region, but this time it's revolved around an axis that's right of the region at x equals 3. That then is going to change everything substantially as far as setup. Try that one. I'll walk around and clarify if you need, and we'll go over it in a minute.
What's your radius? C minus F?
Negatives are bad.
If you set x equals 3, that's the opposite.
What's right, what's left?
Right is 3.
Right is 3, left is x. So right minus left is 3 minus x, not x minus 3. 3 minus x. Sure. So it's easiest, this is the part that was hard for me to get my mind around. It might be easiest if you put a number to something. Say I look at the slice, I know these meet at 1, so let's say I look at the slice that was generated at 1/2. I know that this is 1/2, this whole distance is 3, so as far as what the actual radius is, it's 3 take away 1/2 to get the radius of the shell itself. So it feels like anytime I want the radius, it's the right point of 3, the total, take away whatever the x is to get the radius. That's where I'm getting 3 minus x. The left side is at different places, so that's why I'm calling it x. But the right side is always 3. It's always total distance 3, take away the x, gives you the radius. Does that make sense? Okay? The x is lots of different things. I'm actually advocating all these different slices and putting them together. What about the heights? They're this distance, or this distance, or this distance, or this distance. So I would need the upper y point minus the lower y point. So that's more like square root of x's point minus x squared's point. And from 0 to 1. What'd you get for, did you get 5.34, what-ish there again? Okay. Now let's say we did the same case but with y. Here's the region, here's the axis of revolution, here's the reflection, but using y means we use a washer. Volume is pi, big R squared minus little r squared dy. Big R, here's big R. Okay, it's a horizontal distance, right minus left. The right is 3. The left is, I mean, did we just call this x? Yeah? I mean, do you agree? Didn't we just do this as a 3 minus x, right? But what makes this different now is we're trying to use y, so I can't use 3 minus x. I have to use the point on this curve in y terms. So yeah, it's x, but in y terms, so this is the square root function. In y terms, then, wouldn't that be y squared? So what's big R? 3 minus y squared. Okay. But that really represents 3, take away the x that's on the square root curve. Little r, here's little r. Little r, that distance is total of 3. Take away the x for the y equals x squared curve. So in y terms, points on this x squared curve is 3 minus root y from 0 to 1. Yes?
Why is it on the other one? Why is it sure that it's minus x squared? I thought it was right next to
this, good question, okay, I'm with you. This is referring not to this piece, this is referring to the height, so it's this distance. And
Oh.
as far as upper minus lower, the square root is actually pi. Okay? All right, so with the calculation, those should come out the same. Tonight's a whole lot of this practice. Don't get frustrated, it takes a little while to get mastery, so do your best. Questions on set 93? Set 93.
When did we stop the opposites?
Never. Yeah, never.
No. I know we don't finish the book.
No, we do consecutively through 104, then we do 124,
I want to
137.
stop at like 94.
Do you want to remain in ignorance, or do you want to have it go?
I just want my kids to be good.
What? 93?
Like 5 and 6.
Five?
Did you 10?
5 and 6, what's going on?
Yeah.
5 and 6? Oh, yeah, did I give you initials? I should have given you initials.
You didn't say how many, so I can do very good.
Okay.
Can you do 10?
10, you said 10, not 11, sorry, 10. Yeah. 5 and 6, I should have clarified, I apologize.
22.
22. Did somebody say 18 or something?
Someone did say
18. Okay,
24.
and 24. Okay. For 5 and 6, like I said, I wish I would have clarified and said, hey, it's this many iterations. If you haven't done them yet, let's go. You want to do one together just to walk through it? Okay. 6, you said? Okay, so say 6. I'm gonna, let's call it, use 3 iterations. I'm gonna change it slightly or give more directions. 3 iterations. What's a good x initial? To the 0 of this. You're looking for the 0 is what Newton's method finds. So what's a good guess? Ballpark of something that's close to making it 0.
I did 1.
What is good? Okay. So in terms of what I would like you to at least communicate one iteration of Newton's method and where it comes from formulaically. So it's x naught minus f at x initial over f prime at x initial. And after that, it's recording results. Now, in your calculator, I would probably put in f1, the original function, and in f2, the derivative. So that in my calculator, sorry. Oh, shoot. Third, what was it? Plus x minus 1?
Yeah.
Okay. And then the derivative is 3x squared. What the heck? Okay. X squared plus 1. Okay? Okay, now in terms of what to put in your calculator, you want to start the ball rolling by storing your initial in for x. So 1 store to x. Oops. Apparently it doesn't work like that. Okay. The process then is to take your previous x minus the function, oops, the function at that x divided by the derivative at that x, and you're going to store that over your old x. Now the first time you do that, that's your first iteration. So x1 is 3/4. My new estimate of the zero is 3/4. And I was expecting a decimal, but exactly it's 3/4. If you then just hit enter again, you will be getting new iterations with new x's. So enter again gives you a new of 5986. The third iteration is, oh my goodness, 523,407. 523,407 over 767,077. That's my estimate of the true zone. Okay, that's what I expect to see in the future. I'll try and make it clear what you should do better than I did. I apologize.
Okay, so
Rick?
for we did our own.
Yeah, whatever you do is fine. On a test, I'll be clear. I don't want to grade 18 different versions, so on a test, I would say use this as your first and this many iterations. Yes?
So the bucket asked.
Yeah, so basically, if you were to follow their directions or what they're looking for, you kind of want to know the decimal approximation, so you would do a decimal each time. You'll see that it'll stay, you could keep doing this, and it's starting to be accurate to, you can see how it's the same up to about here. So it's accurate to 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's different at 10. If you did follow the book's instructions, then you'd keep going until it was the same for mine, which I don't require you to do. Does that make sense? I apologize again for the bad directions. I should have clarified. All right, 10. Is 10 still a question? Brian, is that you? Okay. Yeah. Okay, so this is an indeterminate form. In that as x goes to 1, 3 over x squared minus 1 goes to 3 over tiny positive numbers, which goes to positive infinity. 2 over x minus 1 would go to tiny positive numbers, and so that goes to infinity. The question is, all right, so huge positives minus huge positives, what does that equal? Well, that's indeterminate. So when it's this case, you get a common denominator first. You do not take derivatives yet. If I get a common denominator, it is x minus 1 and x plus 1. So the first term I didn't have to change anything, but the second term I would need to multiply it by an x plus 1. Stop me if you disagree. I would then get maybe negative 2x, 3 minus 2, so plus 1. Okay, do you follow? All right, now that is not indeterminate anymore. If I were to look at this, what does the top go to? Negative 1. What does the bottom approach? Given that we're greater than 1, this will be tiny positive numbers, yeah? Do you agree? And this will be tiny positive numbers. So what's a negative 1 divided by tiny positive numbers? Negative infinity. So. Okay. What? I did. It wasn't actually a L'Hopital case, which that kind of creeped me out myself. I thought it would be a L'Hopital case once I put them together, but it wasn't. So no derivative. And chances are, if you took a derivative, you might come with the wrong conclusion. So don't assume it's a L'Hopital case is the moral of that story. Okay, 22. Is 22 still a question for me? You bet. This is a good one. Y equals, this is like an AP for your response, I felt like, and it's multiple parts. Here's y equals e to the x. They say, all right, take this line y equals k to close off the region. And now the region is this quasi-triangular region, right? Call this region R. So they want you to find region R, fairly cleaned up form. So it doesn't really matter whether you use x or y, but how do you want to go about this? Do you want to use x as the variable or y as the variable? I think it'll probably be easier to use x because then we'll be dealing with e to the x rather than log of y. So let's use e. What's the basis of each rectangle or dx? What's the height of each rectangle? Upper minus lower? K minus e to the x, yeah. The next stumbling block is the limit of integration on the right side. I know the left-hand side is x equals 0. That's not hard. But this point, what is the right side of the region? Yeah, so we want to know what natural log of x equals k, so that's at e to the k. Oh, wait, I did that wrong, didn't I? Sorry. Y equals e to the x needs to equal k, so that's at x equal log of k. I apologize, I don't know that's the natural log of k. Right? Now, I suppose that's kind of there, but I think we need to go further based on what they want us to do later. So we're going to go further. Antiderivative, what's the antiderivative? Kx minus e to the x from 0 to log of k. That's k log of k minus e to the log of k. Minus, don't think that 0 won't be anything, it will.
Good morning, Devlin Jaguars. Please stand and join us in saying the Pledge of Allegiance. Ready? Begin. I
Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So I get k natural log of k minus k plus 1.
S through Z will be required in counseling during 7th hour.
That's A. B.
Seventh grade students, the last regular POD meeting is this Wednesday, March 7th, during 7th hour. Please report to your POD groups for 7th hour, and we will be playing a fun game with prizes to review what we have learned this year.
All students are invited to career exploration to the library today during both lunches. Our guest speaker is Victoria Lyson, who started her career in finance marketing and took a 180 and became a physician assistant. She focuses on primary care with families, adults, and geriatric medicine. Stop by to
I
learn
get
about
that k could be 0 or e, but k can't be 0 because they said it was greater than
Loyola
1.
University from La Mirada, California will be in counseling.
Last
for
but not
college
least,
students.
a related rates
30
question.
minutes from Disneyland, and this restaurant
If this grows, what happens to the region R? So they say k is increasing.
If you're curious who the best bakers of Devlin might be, sign up at the counseling for 7th hour and join us in the cafeteria for all parts.
Jaguars guys volleyball tryouts are tonight. Don't miss out on a fun season. 5 to 7 in the main gym.
Senior high students, remember seniors, if you're interested in speaking or performing at graduation or the senior banquet, please see Mr. McCoy.
The Colorado School of Life High School Summer Camp registration opens March 6th. This year's project includes robot, festive functions, control elements, and a challenge to design a creative playground. In addition, 2 camps will use computer software to design and model in 3D. Stop by Council if interested.
Mountain West Credit Union is offering a $5,000 scholarship to those seniors who are a member of Colorado Credit Union and pursuing a degree in business. If interested, stop by Council.
Junior high student council meets today in Mr. Windsor, 8th grade and 10th grade members. Sign up with their social studies via South Tower.
So, plug in and
Deadline
solve
for
it.
turning in permission slips to attend the Skate City event is today. You only need a permission slip if you are riding the bus.
18.
Money for the event will be collected at the Enter Skate City.
The Wednesday practice at Bethel for middle school tennis week is doubtful, and the Monday practice only has a few spots left. However, there are still plenty of options, as all other practice sites are still open.
Category JAG. Attention all students. Congratulations to freshman Kylie Orton for being selected first team All-State in skiing in the Giant Solomon. Great job, Kylie.
Solomon to Jackson Hall, who qualified for the All Geography League. He will be competing on Friday, April 6th to represent Dublin at the next level. Pretty for Jackson. That's all for now. Have a fabulous day.
Thanks.
It's not supposed to be, it's a different.
Okay, so are we doing okay? So maybe the one more. Okay, there's 18, but it could be cosine also, depending on if you use something differently. The C would be different. 24. If necessary. Okay. Because y equals 2x is tangent at the origin, that tells you 2 things. The curve passes through the origin. Can't be tangent if the curve itself doesn't go through the origin, so that means c equals 0. It also tells you that the slope at x equals 0 is 2, which is, in calculus terms, f prime at 0 is 2, which means 2ax plus b at 0 is 2, which means b is 2. Now that you know that, then you can use the fact that it passes through 2, 1. Good. What is?
It's kind of a turbulent time.
Really? Why is that?
Because I joined Ultimate Frisbee, which practices
Did you really?
Tuesday.
Good. What?